Okay, so we're going to continue with our vector discussion. Okay. We did a lot with vectors, I don't know, November, December-ish, but we only did them in 2 dimensions. So we need to kind of flash back to what we did in 2 dimensions, how that affects us now that we're in 3 dimensions, and then we're going to talk about one extra thing. So today we're going to focus on, looks like the dot product.
Is it the triple dot product
Dot products.
Not yet. So today is the dot product. Tomorrow, we're going to do the cross product.
Okay, lab.
Pulls out right.
We're gonna calculate the volume of a bundt cake using volumes of revolution.
Then eat the cake.
Mhm.
Wait, you didn't do that?
We didn't get to do that last year because we had 7 snow days.
You did it.
And then I did it with the kids after graduation.
What? No.
This is why I don't like
You-
Greenville.
We're gone anyway.
No, it wasn't.
In Greenville class, we played
Yes.
Monopoly
Yes.
I was in Greenville class. We played Monopoly like every day.
every single day.
Okay.
You didn't say a word.
You left earlier though.
Those days.
Matthew, were you in the class where we played like
So you guys had like
High-speed
3
spoons?
people in your class. And you had a
Yes,
whole
I
cake.
was.
Yes.
high-stakes
spoons.
high-stakes spoons is terrifying. Like,
Oh,
where could I
Okay, speaking of high stakes spoons, have you played throw burrito?
What?
I want to
I
win.
saw that.
Is that rock paper scissors?
No, it's
If we win the
it's like a
17,
mix
Chloe
of
will give us
spoons and
burritos.
dodgeball and
Oh well, high-stakes
Is where you have to,
spoons
like-
is we play spoons, but there's spoons. They just throw it somewhere in the room.
so you're trying to get
This is
like
insane.
3 of a kind, just like you would kind of in spoons. But when you get 3 of a kind, you just kind of set them aside. But when you get 3 of a kind, let's say like burrito duel or burrito war, then you throw them down. And like a burrito war is everybody like grabs a stuffed burrito and chucks it at somebody, and the person who gets hit loses a point.
What if I beat
I think that's just
Yes.
a form of bullying.
I'd be that one person.
Okay,
That's the best game.
dot product. Okay, so now we're in 3 dimensions. I really hope I'm not gone on this day next year.
Oh,
Because
God.
we just talked about throw burrito.
Wait, is that in the recording?
Yeah, I'm recording. All right,
Why don't you just
dot
stop
product.
recording?
Who can raise their hand and tell me about the dot product from 2 dimensions?
That should be golden.
How do you find the dot product?
I don't know.
I remember coming to it.
Is it in
Okay,
each
so
coordinate multiplied by
Benjamin,
Yeah.
if I had the vector 2, 1 and the vector 3, 4, how would we find the dot product?
Is it
Just-
like
just
6
know it's
1s?
10.
Do you like
Yeah, it's just
multiply the
10.
first one and the second one like separately? So you just do it a third time.
And then we add them together.
Oh,
So
yeah.
yes,
Okay.
we're just going to do it a 3rd time. We're going to multiply the first components, we're going to multiply the second components, and we're going to multiply the third components and add the 3 products together.
This seems very similar to 2 dimensions, except for adding just another number.
And isn't that what you did in your homework on Friday?
Yes.
Everything we did. Okay. Okay. Now, tomorrow we actually going to get into
What makes it different?
Fun stuff.
things that we can only do in 3 dimensions. Okay. Tomorrow, when we talk about the cross product, it's basically the right-hand rule with vectors.
That's
Okay.
right.
Who's in AP Physics
Wait,
too?
isn't that physics?
Yes.
so physics right.
Oh.
Yeah.
Yes.
What's the right hand rule?
I'll talk about it tomorrow.
I don't think I have it now.
So I have vector A is the vector 1, 2, 3. And vector B is the vector -2, 0, 4. Please calculate for me A dot B.
Did it.
I'm not ready. Casey was the last one.
He has the one.
I can see this.
Oh yeah, if you're gone, this year, next year, move your mind, people got the coronavirus. Scared.
500
If you're
in
even here
the
next
United States.
Be here next
So I'm gonna be like,
With the
graduate
cheapest lethality rate.
They just hand me my diploma
And then
and
you
just
just
like
go
go home.
Yeah, what would happen if they canceled school?
I would go online
Everyone
and get
passes.
an GED.
I'm pretty sure.
I really don't know.
Yeah.
I want you to be doing this.
Right?
I don't have those answers for you.
You know, people from the future, wasn't that coronavirus just really mild?
Anthony Brown says that.
What?
Richard, what did you get for A dot B?
I'm still writing it. Okay, I'll just -2 plus 0 plus 12.
Which is
You're gonna get 10.
Good stuff.
Both examples cannot explain.
What?
Wow.
Alright, it's therefore proven all three-dimensional
Well,
dot products are 10.
If you remember correctly, that first one was two-dimensional.
Okay.
All dimensions.
No,
Always
all
are
dot
10.
products are 10. It had a third dimension of 0.
That's
Okay,
zero,
let's
zero,
recall
zero,
some
zero.
properties. U dot V is the same as V dot U. The dot product is a commutative operation.
Yes.
Operation.
Properties all the same. From two-dimensional, three-dimensional.
You tell me.
I don't have all the properties yet.
So you can be coming up with some quality
Okay.
TikTok material.
If we have U dotted with a sum, we can think of this, since the dot product is multiplication, we can think of the dot product as being distributed.
When would this like not be true? Like U times V equals U times U. Like why do we have to declare
Because not all operations are commutative.
Flute you.
When we do subtraction, subtraction is not commutative.
that? But we're multiplying. So
I know. Tomorrow, when we do the cross product is not a commutative operation. It's multiplication, but it's not commutative. We have to declare it. It's not a given. Okay? All right.
See as many people as you can get, or just the short straw. Just to go
Can we be done? Acting like children? Okay. Multiplying by a scalar is tied with the operation of a dot product. Dot product is multiplication. So this is a scalar times the dot product. So you can either do the dot product and multiply by the scalar, multiply the scalar to U, and then do the dot product. Yeah, I don't like how I wrote that. Or do the dot product with U and C times V. So the scalar either multiplies to a vector first and then you do the dot product, or you do the dot product and then multiply by the scalar. But it does not distribute because it's all multiplication. Okay. What's the dot product with U and the zero vector?
Zero.
Yeah. Okay. When would that be false? I don't get the point of saying that.
different axioms.
Like if you're multiplying by 0, it's like given that.
It's the same either way. So this is the zero vector. The dot product is a scalar, it's not a vector. Okay, so when we take the dot product of U and the zero vector, so 0, 0, 0.
Wouldn't it still be 0 if you did a scalar as well? Scalar by
But
0.
it would be the scalar vector. The zero vector is different than the zero scalar.
But wouldn't both of them make it equal 0?
But they're two different kinds of zeros. We have the bold zero and the non-bold zero.
So like a 0 vector would that just be like nothing? Isn't that nothing? That's the origin, like a dot.
Okay. Here's the most important. V dot V.
V squared.
Now I'm gonna do
Magnitude of V squared. Yes. Where is your hand to tell me that? Okay.
they're all the
Cool.
Caleb's being sassy today.
Gonna be a great week.
Okay. I have not been looking forward to this week. We've had a time change. We're all tired and grumpy. It's the week before spring break.
Yeah.
With a full moon.
Friday the 14th.
State basketball on Friday the 13th.
And now.
Don't forget to wash your hands.
Coronavirus.
Corona.
Like, how do I even compete with that?
You can't.
I didn't
You can watch Star
What?
Wars.
You could teach standing on a stool.
That's
You could learn how to
That's
juggle.
dangerous.
You could learn how to
Or
juggle.
standing under a ladder.
Juggle while standing on a stool is also under.
Make sure the
We'll
lights are
also
flaming.
teach you.
Okay, the angle between vectors.
With a black hat.
Oh, that's the cosine thing. Isn't
Oh,
it?
the cosine of theta equals.
Very good kick.
That's all it means. That's all it, it's like the magnitude of something times the other one over something.
You got most of it.
You got the.
Ah, the dot product should probably be involved if we're talking about it today.
I gotta say, that was a good job, Caleb.
What about that one form? Remember, it's like the shadow of one vector or whatever.
We'll talk about that one next.
Oh, that one was
I have a
fun.
question.
Yes.
Is this in degree or radian?
Have you guys seen the
Degrees.
Oh!
Now it's in degrees.
Remember this is
I'm
what you
gonna
guys.
let us do degrees right now.
It's the Pokemon.
Is that okay? Do you not like that?
Are you trying to?
So like, wait, are you saying like if we accidentally are in radians, like you'll count off, or is it either?
Absolutely not.
Just label. If you're in radians, label radians. If you're in degrees, label degrees. Okay, so we are going to find the angle in between 3, -1, 2 and -4, 0, 2. Okay?
It's like our
Pod
area
4,
code.
calculate the dot product. Pod 3, calculate the magnitude of U. Pod, you guys, 6, calculate the magnitude of V.
So,
What is new, bro?
The magnitude.
oh shoot, yeah. Oh my god.
What do you get for Oh.
All right, what's our dot product?
Eight. -8.
-8. What's our magnitude?
Square root of 14.
Magnitude. So making sure that this is a product in parentheses, we can take the inverse cosine of this fraction to get our angle.
What mode do we have?
Degree, since I want a degree answer.
Oh.
Why do you have parentheses?
So that when you put it into your calculator, you remember that that denominator needs to be in parentheses, otherwise the operations will be mixed up.
What if you have like the fraction?
So, if you have the fraction thing, that's fine. But if you use the division symbol, division and multiplication are tied. So it would read -8 divided by radical 14 times radical. If you didn't group them together.
Is that not the same?
No.
Andy, you get one.
Weird. Have you seen this on that like one thing?
Your calculator would do this first
Oh.
and then multiply by 20.
So it's a fraction. Use calculator.
Okay, and so not everybody does that.
Have you seen like that thing that like blew up on the internet, or like Twitter thing where it was like a really simple like math Wait a minute, question,
It's like
to calculate and like depending on where you're from.
Say, why your calculator say
Like,
good?
because they- they-
Oh, no.
order
Got it at Target. You know the drill.
Yeah, or something.
No, it's because people forget.
118.
Five,
Point what?
six.
5.
6-1.
3 decimal places in AP Calculus.
3 places. I feel like it's 3 places for everything unless otherwise stated.
Okay,
Sig
Now-
Celsius.
Let's go to five.
what?
Celsius or Fahrenheit?
Yeah.
Kelvin. That's not a degree.
First of all, if 2 vectors are orthogonal, that means their angle between is 90 degrees.
90 degrees.
And if we have 2 orthogonal vectors, I would know that before I typed into my calculator because the dot product is 0. If your dot product is 0, you have orthogonal vectors. Okay. All right. Now, when we were in 2 dimensions, we could break up our components by taking magnitude times the cosine of theta and magnitude times the sine of theta. Okay, well now that we're in 3 dimensions, so this is 2 dimensions, like real numbers in 2 dimensions.
Is that why there's like an extra line? Is that like 2 dimensions?
All real numbers.
You don't remember the sign for all real numbers?
All real numbers in 2 dimensions.
Yeah.
Is there another symbol for 3 dimensions?
Well, it's just a 3.
So now that we're in 3 dimensions, well, how do we get the 3rd dimension? Okay, we're going to have to do something a little bit bigger. So if we want to break up our components, we're going to kind of have to go to plan B. All right? So this is what I want you to think about. Here we have our, yeah, sure. Okay.
That looks like a Y. It's like slightly skewed.
Here's our vector V. Okay.
Yes, Ben.
Here's our vector I. Here's our vector J. And here's our vector K.
Oh, so it's like D comes out of, kind of.
Yeah.
It's like that, okay.
I don't really know how to draw it.
Oh, I thought that was going backwards.
Yeah, you put up like a little,
You should take
just like,
You
should
get
take
it.
idea.
That's what I'm saying. It's hard to draw this stuff.
yeah.
It is hard to draw this stuff. Okay. So what we're going to do, because we're kind of running out of trig functions here, but for us to figure out what's happening in 3 dimensions, we have to take into account these 3 unit vectors. So what we're going to do is we're going to imagine finding the angle between V and each of the 3 unit vectors. So if we were going to find alpha, alpha is this angle right here. Okay, the angle between I and V. If we're going to find alpha, we'd set up the cosine of alpha is the dot product over magnitude times magnitude. Okay, well, people, what's the dot product of V and vector I?
Should it be 0?
They should not be 0.
No.
I don't know.
I'm not supposed to know.
We don't know.
Is it supposed to be parallel?
Is that just D sub 1
Yes.
over
Oh, so we don't know.
magnitude?
Yes.
Oh, because I is on like the axis.
So I is 1, 0, 0. So when we take the dot product with V1, V2, V3, only V1 gets multiplied to 1, the others get multiplied to 0. And then we know the magnitude of I is going to be 1.
Why do you have to
Okay.
do cosine?
So this is the formula we were just using before. The cosine of theta equals the dot product over the product of their magnitudes. I'm using angle between two vectors. That's what I set up. Okay. So now we have the cosine of alpha equals this. If I wanted to solve for that component, the V1 component is magnitude times cosine of alpha. Okay.
So the same exact.
What?
Not the same thing
Oh, I think you were trying to find the
Well, you tell me. Now let's talk about J. In between J and V is angle beta. Okay. So the cosine of beta is going to equal the dot product of V and J over magnitude of each. Okay. When we take the dot product of V from 0, 1, 0, what are we going to get? Well, how about this of 2? Right? If we take the dot product between this and 0, 1, 0, these are going to multiply together. The rest are going to be 0. And the magnitude of J, we know is going to be 1.
super secret free challenge.
So here again, our second.
So they're all just going to be cosine, cosine, cosine.
Yes. Yes.
I will see other
Still
classes with super secret free challenge.
So now we're going to talk about.
And then us quiz.
Yep, I do.
Theta.
Yeah, we have high day cards.
So this is gamma.
Cozy.
The cosine of gamma.
How do you
It's
draw
gonna-
like a gamma? Like just like a big line.
It's like, but this is like kind of a squiggle right here. Okay.
Draw the whole.
So V dot K over magnitude of V, magnitude of K, which is going to be V3 over magnitude V. So what we can write is that our vector V is magnitude times cosine alpha I plus magnitude times cosine theta J plus magnitude times cosine gamma Now what these are called right here, these are called the directional cosines. And I'm actually going to ask you to find the directional cosine.
They're gonna give us the vector components and then we can find magnitude.
Yeah. So our vector is the vector 2i plus 3j plus 4k. And I'm going to ask you to find the directional cosines. All right, so first of all, square root of 4 plus 9 plus 16 is 29.
How can we be sure it's equal to this?
2 squared plus 3 squared plus 4 squared.
Yeah, but
You're not buying it?
what if it isn't?
Okay. So we need the cosine of alpha is going to be 2 over radical 29. The cosine of beta is going to be 3 over radical 29. And then the cosine of gamma is going to be 4 over radical 29. So you need to do inverse cosine 3 separate times for these 3 directional. So how about pod 4, you've got alpha. Pod 3, you've got beta. Pod 6, you've got gamma. What did we get? What did Matt get? Or what did...
With Matt.
That's good.
Zero, 3, 1.
So I still don't know how to go with that.
Yeah, we got you. We're always here for you.
Yeah, okay. I felt
I
terrible.
want to sanitize that.
Because I feel like
You have a 5% chance.
I feel like I needed to look you up there. And I didn't.
All right. Pod 4, what is alpha?
68.199 degrees.
That's very.
Beta.
56.145 degrees Celsius.
Gamma.
42.031 degrees.
Those are our directional cosines. So this is the angle between vector v and vector I. This is the angle between vector v and vector j. This is the angle between vector v and vector k. Another fun fact.
I love fun facts.
So let's go back to our directional cosines. I want us to consider cosine squared alpha plus cosine squared beta plus cosine squared gamma. Any inklings about what this is going to be? Chris says 1.
Yeah, assuming it's gonna be 1 because that's right.
Okay.
Unless you have a cosine squared, it's automatically
Okay. So here's our directional cosines. I replaced them with the other side of the equal sign. So I have 3 fractions that I'm adding together. What's every denominator?
29.
But this is generalized. Magnitude of v squared, correct?
Yeah, but just one spread.
Our numerator is v1 squared plus v2 squared plus v3 squared.
And what does this mean?
Seems like root
Why is that 1?
This is the magnitude squared. Right? This is what's underneath the radical for magnitude. So without the radical, it's magnitude squared.
And why do we need to know that?
You don't, I just wanted to show you.
What part of fun facts don't you understand?
They're fun.
The fun part, apparently.
Okay.
Okay.
Sorry.
I want to remind you how we do projection vectors.
I knew it.
The projection of V onto W is V dot W over magnitude of W squared times W. That will probably come up in your homework this evening, so I wanted to make sure that we know that.
Oh, wait, I should probably write it down.
Yeah, so since we're in 3 dimensions, this is just going to be a 3-dimensional dot product, a 3-dimensional magnitude, and then this is just going to be a 3-dimensional vector. We're going to multiply that scalar too. So it's not going to change the process. It's just a little bit longer since we have a 3rd dimension with everything that we're. All right, tomorrow we're going to talk about a cross product, and then notice how we just go straight into a quiz.
Because
I
we're
don't.
in a college level class.
We're preparing you for college.
Yeah.
Nothing.
It's not a bad. It's a very, very computational heavy quiz. Like it's not a lot of
You know
like.
that we're thinking.
That means you're
It means you're gonna be using your calculator a lot.